Unit 1, the alphabet and grammar of geometry, lesson 1.5, algebra review. Students, record the date, time, location that you're watching this video. Don't forget to get a parent guardian sign off. Please turn off your distractions. Now for this geometry class, there are some very essential algebra skills that are going to be used quite frequently in this class. And it's very important you have these absolutely mastered. That means you can do them with little or no assistance. So we're going to review them now. You're going to review them in class. You'll see them several times throughout the year. Step 1 is to be able to deal with computational math and fractions. I know that's just your favorite word. Next, you need to be able to obviously solve for variables consistently and accurately. And then the third skill today is we're going to learn how to add, subtract, simplify, multiply, and divide radicals. Radicals, you might know them better as square roots. Now, for a few of you, when we get to the section on radicals, if you are like, I've never, ever seen this before, Miss Way, you need to come and carve out some extra time to review with me at lunch or after school, or Open 1B. We've noticed a few of the Common Core integrated classes that students have come in prior to my class occasionally don't even touch on radicals at all. If you had Mrs. Gangle last year or Mrs. Hawkins from our junior high or Mr. Tuttle from junior high, you've definitely seen them. But if you've possibly come from another school and you honestly haven't seen any square roots or radicals at all, it is important you get extra review with me. I'm going to be teaching them as a review, not as first exposure. So first, we're going to learn how to do computational or review math with fractions. The most important skill is for you to differentiate when you can cancel and when you can cross multiply. You can cancel when fractions are dealing with multiplication or division and you're on the same side of the equal sign. So notice here, we're on the same side of the equal sign. Since we're on one side of the equal sign and we're not adding or subtracting but just straight up multiplying, you can cancel to your heart's content. So let's cross out, we know the 4 goes into 12 3 times, that's once. And then you can go this way, 3 goes into 9 3 times, 3 goes into the 6 twice. And once you've reduced everything possible, then you just multiply straight across. So our answer here, straight across, 1 times 3 is 3, going this way. And 2 times 3 is 6. And then you can reduce one more step, obviously, and our final answer is 1/2. So when you're working on the same side of the equal sign, you can cancel to your heart's content. But when you're on opposite sides of the equal sign, like we are here, you cannot cancel across that equal sign. Instead, we cross multiply, and I'm going to show you a little shortcut. The key to multiplying is actually not to multiply. It's a factor. The key to multiplying is not to multiply. It's to factor. I'll show you what I mean. So we're going to multiply this way, and that's 4 and x. Bring down our equal sign, cross multiply with me, 12 times 9. Now, rather than multiply 12 times 9 out, you're simply going to write 12 times 9, because the key to multiplying is not multiplying, it's factoring. We want to get x by itself, so we're going to divide both sides by 4. Now we're working on one side of an equal sign. Now you can start factoring to your heart's content. I know 4 goes into 12 3 times. 3 times 9, 27 was our answer. The key to multiplying is not multiplying, it's factoring. In division, when you divide, of course, by a fraction, it is the same as multiplying by its reciprocal. So immediately, what we are going to do here is we are going to flip that second term into its reciprocal. So I'm going to go 5 over 9. We're going to go times 12 over 10. That's the reciprocal. And now that we're working on one side of the equal sign only, and we're multiplying, now you can start canceling. 5 goes into 10 twice. 3 goes in here 3 times. 3 goes in there 4 times. And you can even cancel one more. 2 goes into the 4 twice. Now we're going to go straight across. 1 times 2 is 2, straight across over 3. If this is stuff you'd like to remember how to do, I would write 3 little bullets and pause the video and write what are the 3 main steps that we did here, and what were the 3 main steps that we did here. Pause the video and write out those 3 main steps. Restart. Welcome back. Now, adding and subtracting fractions take a little bit more footwork. First, you have to find the lowest common denominator. So between 2 and 7, it's going to be 14. So I'm going to put a little 14 here, a little 14 there. And I'm going to do a miniature version of arrow in, arrow out. 7 goes into 14 twice. A little 2 there, 2 times 5. And this is going to translate 10 over 14. We're not solving for a variable, so we can't clear the fraction completely. Arrow in, arrow out. 2 goes into 14 7 times. 7 times 1. So I'm going to do 7 over 14. Once you have the same denominator, now you just add the numerators without touching that denominator. In general, you can leave it as improper, although you should be familiar with the mixed numbers if we need to graph. 14 goes in there 1 time with 3 left over, and that would be your mixed number. Let's try that again. So first we're going to find the lowest common denominator between that 4 and that 6. You're looking for the absolute lowest thing possible. And I know that's going to be 12. I'm going to go to the left to give you lefties a chance. We're going to go arrow in, arrow out. Four goes into 12 3 times. 3 times 3 is 9. And then our new denominator is 12. Watch that minus sign. 6 goes into 12. Arrow in, arrow out. 2 times. 2 times 4. 8 over 12. Once again, now that your denominator is exactly the same, you can now add or subtract the numerators accordingly. That's not improper, so we're done. This page and the next one you're going to do on your own. Please do this on your own. Don't just copy the answers. Do this on your own in pencil, then grab your red pen, like you're supposed to, and correct in red. Pause the video. All right, welcome back. Again, over here, we're on one side of the equal sign only, so we're going to cancel to our heart's content here. 5 goes into 25 5 times. 7 goes into 28 4 times. Nothing left to cancel. You should have gotten 4 over 5. We're going to cross multiplying, and the key to multiplying is not multiplying. It is factoring. Those of you who picked up a calculator for the 3 times 36, you were cheating. Don't do it. No calculator at all. And you're like, but Miss Way, it's 3 times 36. You're right. Guess what? You don't actually have to multiply it. We're going to factor it. So don't actually multiply. Just leave it there. Let's factor this out. Divide by 12. And you should have gotten 12 goes in there 3 times, and 3 times 3, you should have gotten 9. Dividing is the same as multiplying by the reciprocal, so I'm just going to flip it into its reciprocal, which is 14 over 64. I'm going to start canceling where I can. I know that goes in there 8 times. And 7 goes in there twice, and 7 goes in there 3 times. I know the 2 can be taken into the 8 4 times. Now we multiply straight across. The only thing left is a 1 down below, 12. That doesn't look like a 1. It looks more like a 7. Let's change that. There we go. If what I just did confused the daylights out of you, I can clear that up in about 10 minutes. Face to face. Here, you start by getting the lowest common denominator, which for 2 and 9 is going to be 18. Put a little 18 there. I'm going to do a miniature version of arrow in, arrow out. 9 went in there twice. This ends up turning into 10 over 18. Bring down that minus sign. 2 goes in there. Arrow in, arrow out, 9 times. That's going to be 9 over 18, and you should have gotten 1 over 18. Okay, that was skill number 1, working with fractions. Skill number 2, solving with variables. We've done this a few times in class. I just want to emphasize some of the helpful rules. So we're going to follow PEMDAS. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. Ready? Step 1, we deal with exponents and parentheses. This negative sign technically is -1. Whenever you see a stray negative sign, add the -1. Now we're going to circle, distribute, physically circle and distribute. That is super important. Physically circle and distribute. Draw the distribution lines. Now we're going to go back, underline your variables. Double underline your non-variables. We're going to collect like terms, left and right. Here I have -1 plus 8 and then -6 plus 24, positive 18. And then here we have 10K. Left and right, nothing left to clear, so now we can start canceling stuff out. Please, only one step at a time. Physically cancel it out. If this were a test, what I'd highly recommend you do is to take that time and take that variable and pop it right back into the actual equation and go ahead and perform a check. There's no reason for you to get algebra wrong on a test because you can always run a check by simply taking your answer and plugging it back in wherever you see that variable and make sure it actually balances. So that's simply solving for x. Then you're going to see stuff like this where you have two variables. We'll get to this when we see x and y when we deal with lines. This is very common when we're working with lines. And one of the first steps in working with lines is isolating the y. I'm going to give you a little storyline. If this storyline makes sense to you, fabulous. If it doesn't, just do it however you can remember, okay? But here's my storyline. You have 4x minus 12y equals 36. We're at a party here. We have two different rooms, okay? 4 and x is a date, and 12 and y is a date. Guy Y, girl 12, girl X, guy 4, and then we have a stag over here, which is a person without a date in the other room. That's my storyline to start. Here we go. In this story, guy Y, no, this is not sexist, guys. This is just a story, so roll with it, okay? Guy Y gets some sort of attitude. I don't like this place. The music is bad. The pizza is the wrong kind. None of my friends are here. Whatever. Okay, Y gets an attitude. But this Y guy is not going to be the nice, upset person who just removes themselves. Instead, it's going to make everyone around them upset. So who leaves the room first? I will tell you who doesn't leave the room first. The date does not leave first. The date is attached to the Y. So the date, she's all dressed up, she's at a party, she wants to stay, so she's going to try to convince Y to stay. Oh, honey, I'm all dressed up, please let's stay. So the first ones out of the room is going to be the other double date. They're not going to watch couple drama. All right, and then we have here, so now we have negative 12, y equals I'm going to bring that x forward. You'll understand why in just a second. Okay, now y still has an attitude. So now the date's going to give up. So ready? We're multiplying, and the opposite of multiplying is dividing because we're breaking someone's heart. Think of what's the most painful operation between add, subtract, multiply, divide. If you're going to break somebody's heart, you are dividing their heart in half. So we're dividing the date, and the date's going to come over here, and she's going to gossip to every single individual what a horrible date this was. So we've got y equals negative 4 over negative 12x minus 36 over 12. Last but not least, we're going to clean this up just a bit. Double negative makes a positive, and 4 goes into 12 3 times. So this is positive 1/3 x. 12 does go into 36 3 times, minus 3. Now, why did we bring the x forward? Because now you should recognize this form. Y equals mx plus b, commonly called the equation of a line slope-intercept form. Ready? You try this page completely on your own. Restart the video when you're done. Pause. Welcome back. Let's see how you did with this basic algebra. So we're going to Circle and distribute. Negative 7x plus 8 minus 8x equals negative 8x. Double negative makes a positive 8. I'm going to collect like terms. Yes, you were right. X was 0 there. 0 is a number. 0 is a potential answer. The only way negative 7 times anything equals 0 is if that unknown is 0. Isolate the y. Again, y is the date with the bad attitude. So everyone's trying to get away from y. The couple's going to go first. So we're going to add 6x both sides. I have 9y. I'm bringing the x first. 6x minus 27. Then finally the date figures out I'm not going to stick around, so we're going to break and divide the couple up. And she's going to come over here and gossip to everyone. So I have y equals, clean it up just a bit. 3 goes in there, 2 and 3. I have 2/3 x minus 3. Okay, that is the done with the basic algebra. Now we're going to deal with radicals. It is super, super, super important, if you've never, ever seen these before, that you come and get a little extra help. I'm assuming that you have seen them, so I'm going to approach it as a review. To simplify a radical, I have 2 methods. I call it going out for a date method or getting out of jail. If you have a third method that you learned in a previous algebra class and it works for you, for goodness sake, don't change it. All right? So the going out for the date method, you start by doing a factor tree. So we're simply going to factor all the way down, starting with the simplest, smallest factor we know. If it's even, I'm going to use a 2. And I'm going to do 2, and I know 54 goes in there. And I'm going to keep going. 2, and then half of 54 is going to be 27. Now I know that 3 goes into 27, and 9, and then a 3 and a 3. Now you're only looking at what's commonly called, or I call, the leaves. These are the leaves. Ready? The yellow are branches. Do you understand what I mean by branches? They get branched. So your eyeballs do not look there at all. In fact, if you need to, cross them out. Now you look only at the leaves. If you have a date, they get to go out, but when dates go out, they are a single couple. You look at any of the 2 leaves, there's a date, they come out. This last 3 has no date, stays home. So let's look at what we have. We have on the outside of the radical a 2, and when you go on the outside, we're multiplying, not adding. 2 times 3, square root, and we have this 3 here. Last step, we clean that up a bit. 2 times 3, that's 6 root 3. That's called simplifying a radical. Now the other method is getting out of jail. And what I'm going to do is I'm just going to prime factor 54. Watch what I do. You pull it all down to primes. I know 9 times 6 equals 54, but I'm going to prime factor 9 and 6. So 3 times 3 is 9, and 3 times 2 is 6. Now here's my getting out of jail storyline. You can't get out of jail by yourself. But if you can get a partner, you can break out of jail. But only one of you gets out alive. The 2 and the 3 don't have a partner. These multiply. 15 square root 6. Use any method. If you have a different method, I know some students have done what's called upside down division method. If you recognize that, you are welcome to use it. Go ahead and use either method, and I'd like you to simplify these radicals below. Pause the video. Welcome back. Let's see how you did. Ready? All right, this is going to be 9 times 7, and then 3 and 3. Just looking at the leaves, the 3's have a date, they come out. And then that 7 there does not have a date, stays under the radical sign. So root 63 is going to be 3 root 7. We don't look at that 9, that's a branch. 108. You take out the dates. Doesn't matter which pair comes out. We're going to get 6 root 3. Again, on the outside, you multiply, not add, multiply. So if I have a 2 and a 3 on the outside, that becomes 6, not 5. That's called simplifying a radical. Now we're going to add or subtract a radical. The best way for me to teach this is pull on what you already know. I have this actually color-coded. Let's take a moment. If we have negative 7z plus 3x plus 8y minus 2x minus 5y plus z. If I ask you to simplify that algebra, let's do it together. First, I'm going to collect like terms. So I'm going to pick up my z's, negative 7z plus 1z. That's going to be 6z. Watch very carefully because there's so many terms. I like to cross stuff out as I use them. I'm done with that, done with that. Let's go for our x's now. 3x minus 2x. That's going to be plus 1x. I'm done with that. I'm done with that. 8y minus 5y. That's going to be minus 3y. Done with that. I'm done with that. Okay, the method you just used to collect like terms is the exact same method you use for radicals. Notice when we collected the negative 7z and the 1z, we don't have z squared there. You don't touch the variable. Same thing when we collected everything else. Ready? Watch very carefully. Negative 7 root 2 plus 3 root 5 plus 8 root 3 minus 2 root 5 minus 5 root 3 plus root 2. If you watch very, very carefully, in fact, why don't you physically trace this down with me so you can see how these connect. The same rules that we used for the variables, we are going to use for the radicals. The exact same rules. Ready? Let's underline. We have a root 2 here, and we have a root 2 here. That's like our z's. Underline them. That's negative 7 root 2 plus, that's technically a 1 root 2. So I end up with 6 root 2. You don't touch the radicals, just like nothing changed with the variable. Let's go. Root 5. So there's a root 5 and there's a root 5. So that's 3 root 5 minus 2 root 5. That's going to be plus 1 root 5. You don't touch the radical sign. Last one. 8 root 3 minus 5 root 3. 8 minus 5. That's going to be 3 root 3. So do you understand what I mean by collecting like terms? Our like term there was root 3. Our like term here was root 2. Our like term here was root 5. Just like we had like term variables. Radicals follow the same rules as variables. Let's try a pure radical. Okay, so before we do that, it is important that we simplify everything first. So let's come here, and every single term underneath, you ask yourself, can it be simplified? And if it can, we break it down. Ready? The 20 can be simplified. So can the 18. Do you see the 1 and 5? You can't go anywhere with that, so we're not going to do anything with that. Watch very, very carefully. Ready? So right here, there is a pair of 2's. We're going to bring it out. Technically, what's there is a 1. So 2 times 1, that's going to become negative 2, and then the 5 remains, root 5. Ready? We have a pair of 3's, and we're going to bring out one pair of 3's, and there's a 3 on the outside already. So that's going to be minus 3 times 3, that's 9 root 2. That 5 can't be broken down, so we just do 3 root 5. There's nothing we can do with it. Coming back here, we have a pair of 3's. The 3's are going to come out. 2 times 3, that's going to be plus 6 square root of 5. Now, circle the radicals that are exactly the same. I have a square root of 5, square root of 5, and a square root of 5. We collect them just like you would variables. So negative 2 minus 3 is negative 5. Plus 6 is positive 1. So this is positive 1 root 5. I have dealt with those. I like to cross stuff out after my brain's accounted for it. Minus 9 root 2. And you are done here. Why? Because the radicals are not the same. Just like if I had 1x minus 9y, I'd be done there too, because the radicals are not the same. So step 1 is you factor. Step 2, factor and simplify. Step 2 is we collect like radicals. Now take what you just learned and put it to practice right there. Pause the video, do that on your own. All right, welcome back. Ready? Let's double check and see what you did here. So the 5, you can't do anything with it because it's a 1 and a 5. So I'm just going to bring that down. I have negative 2 root 5. I'm going to break this down. That's 2 and 9, 3 and 3. That 3 can come out. Little baby 3 there. And that's going to become minus 9 root 2. 1 and 2, can't do anything with that. So this is going to be plus 3 root 2. And that's 2 and 10, 2 and 5. Should be able to bring out the 2 there. 2 times 2, that's going to be positive 4 root 5. You should have collected like terms, so the root 5s can collect. Negative 2 plus 4, that's going to be 2 root 5. And then I'm going to collect the root 2's. Negative 9 plus 3, that's going to be negative 6 root 2, and we are done. Make sure you take your red pen and correct whether you did that correctly. And if you have serious questions about this, come see me. I'll give you extra practice. Okay, that's adding and subtracting radicals. Now we have to be able to multiply and divide. Multiply and divide. And the trick to this is working with outies, innies, and then we simplify. Outies, innies, simplify. Say it again. Outies, innies, simplify. One more time. Outies, innies, simplify. Let me show you what I mean. First, we're going to multiply the outies. Those are the things outside the radical. So outies, physically circle them. Now watch, the key to multiplying is not multiplying right off the bat. We might need to factor. There's your outies. Now circle your innies. We're going to put them under the radical sign. Notice I am not immediately multiplying. Okay, my outies, I can multiply, just get that off the base there. That's 21. Now my innies, I'm going to continue to factor because I'm going to prime factor that 6 down. So I have a 3, and then that 6 is 3 times 2. Why did I do that? Because now I can see we have a partner and we're going to break out of jail. Three times 21 is 63 root 2. Outies, innies, simplify. Outies, innies, simplify. You try that on your own for the next one. Pause. Welcome back. Let's see how you did. Outies, innies, simplify. First, I'm going to multiply my outies. 7 times 2. And then here I have my innies, 5 times 15. Once again, the key to multiplying is not multiplying, it's factoring. That 5, and then this is going to be 5 times 3. You have a partner to break out of jail. 5 times 14. That's 50 plus 20. So that's 70. Square root of 3. outies, innies, simplify. Same thing with dividing. Outies, innies, simplify. This gets a little bit more involved, but it's not that hard. We're dividing by a radical. Step one. Okay, we're going to focus on our outies first. Our outies are the 5 and the 20. So I'm going to start they can divide. Outies divide. So we do our outies. That's 1 and a 4. So I have 1 over 4. We just took care of our outies. Innies, we're going to break that down. That's going to be 3 times 4. And my down here, that's 3 times 2. That's 6 times 3 again. And now we can simplify whatever's under the radical sign. So the 3's cancel. The 2 goes into the 4 twice. And we're left. So here's the final product of our outies and innies. After we do our outies and innies, we have root 2 over 4 root 3. Bring it over here. Outies, innies. Now to simplify, you cannot leave a radical in the denominator. That's super important. So to get rid of that radical, we multiply top and bottom by the exact same radical. 2 times 3 is 6. 4, now careful there, we've got 3 times 3. We've got a partner in jail here. Guess what? They can break out. See those pair of 3's? Go like that, circle them. They break out of jail, but only one makes it. Our final product, outies, innies, simplify. Root 6 over 12. Outies, innies, simplify. I want you to try the same process on this problem on your own. It's okay if you're wrong. Just do whatever you can do. Pause the video, try it on your own. Okay, students, welcome back. You should have a red pen in order, ready to go. Okay, step 1, we're going to deal with our outies. So we know 6 goes into 42 right off the bat. So I end up with 1 over 7. The prime factor, that 32. All right, I know that's 4 times 8. And then I have down below 4 times 3. 4 times 8 is 32. 4 times 3 is 12. The 4's cancel. Now 8 and 3 do not mingle at all. There's nothing else you can factor. So ready? There's your outies and your innies. Root 8 over root 3. Outies, innies. Now we simplify by multiplying by that radical, numerator and denominator, down below. So I have 1, 8 times 3, 7, and then down here I have the now root 3 times 3. We have a double. They can break out of jail, but only one of them makes it. Your final product should be, not quite the final product. I'll show you why it's not the final product in just a moment. And that's 21. Now, you got that down, cleared up, but there's one number up here that still has a date. 2 times 2 times 2 is 8. Times 3 over 21. That pair of 2's can come out. Your final complete simplified version is going to be 2 square root of 6 over 21. Now, if you got that right, kudos. Woohoo! If you were not correct, it is super important that you take a moment and you analyze what went wrong and what would be the steps you need to do next time, and actually write that in the margin.